Hi, this is Mrs. Rodolfi, and I'm going to go through the Unit 2 study guide with you today. Remember to first try it on your own to check your own understanding and see if you can do it on your own first, and then use this video to check your answers and get extra support for those that you're struggling with. Remember to always show your work or explain your reasoning with words, and then I encourage you to use the desmos.com/calculator to check your answers, because you will be able to use that on the test and on all the tests from now on in this class, as well as most of the LEAP test. So you really want to get familiar with Desmos to help support finding your solutions. For number 1, identify the independent and dependent variables in the situation. So if we're given a verbal description, we want to think about what are being measured. So Taylor turns the garden hose to the pool. So she's filling up her pool. So I'm going to assume we're measuring the amount of water. So our variables would be amount of water. So maybe like gallons usually is how we measure when we're filling up a pool. And then as time passes, the water fills the pool. So we're also measuring the amount of time that passes. So then we have to think about which one depends on the other. And on the time. Well, time is usually going to be independent. Time is going to keep going no matter what. So it really doesn't, time doesn't really depend on anything else. So the of water depends on the So our independent variable would be time. Or amount of water. And so then we have a graph. On a graph, our independent variable is always the x-axis. So the distance in miles is our independent. Be the cab fare in dollars. So that's dependent. So independent is always on the x-axis. Dependent is always on the y-axis. So in this case, how much I'm going to pay for my cab fare depends on my distance in miles. You know, if you drive further, you're going to pay more for your cab. Remember to answer these questions. So this goes over the key features, concepts. So I would definitely take out that foldable, work through these problems on your own first, remember, and then use this video to check. All right, so 2, does the graph represent a function, why or why not? So remember, we can use the vertical line for as long as it's only touching one point at a time on this line, then it is a function. So yes, it passes the vertical line. And then another way to write reasoning for that is each input has output. I also strongly encourage you to be using a 3x5 note card to add any notes that you may need. Let's go back to number 1. Let me just model. I won't write everything on here, but I just wanted to model a few things to give you ideas of how you could use independent, dependent variables are. You could draw a little graph here and put independent variable, dependent And then when you're taking the test, it can help you remind you. And then maybe if you want to write the verbal description, add that. Remember to write small because you only have this 3x5 note card, so really pick and choose what you really need reminders. The graph representing a function, you'd say function, each input x has exactly, I can't spell right now, that's a C. Exactly one output. You could draw a picture of a graph to give an example if you're a more visual learner. So you make this your own and what helps you, but I'm just trying to give you. So I'll add some things to that throughout the video as well. Number 3, is the relation continuous or discrete? How can you tell? Well, remember, there is a line connecting. Remember, it doesn't have to go forever. There are endpoints, if there's no arrows, but that's still a line connecting the points. So continuous, showing, and we can even show the endpoint so you know, oh, okay, it's okay if it ends, doesn't go forever. And then would be, I'll actually draw a graph here, would be like just data points, no line connecting them. So identify the y-intercept of the relation shown. So remember, this is the y-axis, this is the x. So your y-intercept is where it crosses the y-axis, always write as an ordered pair. So that would be, label that y-intercept. And then that ordered pair is at -3, but remember the x value is always when x equals 0. So if that's a reminder, you need y-intercept write as ordered pair when x equals 0. Or even write the ordered pair 0b. And remember, b stands for y-intercept in the slope-intercept form, so that's why I put a b there. So that stands, or you can show you. Identify the domain and range. Domain is the x, and then range, what it is from furthest left to furthest right. So if it helps you, you're going to draw a vertical line going through the very end. It's from the very bottom to the very top of the line. So like, where's the lowest point of the line? That'd be here. Where's the highest point of the line? That's here. And around it to help find the width and the height. So for x-axis, this furthest left point is at -9. So remember, I would do the D. If it's a solid line there, right here, that's a data point, that's a closed circle. So, and remember, these inequalities always face the same direction, less than or equal to, and then a range from bottom to top. So bottom here is at -9 on the y-axis. And then this point is, this line is a little number, but if we really wanted to be exact, I would say maybe that's like 0.3 or so, but it won't be anything like that on the test. This graph just is a little off there. So if you said 0, I would accept that in this case, but technically it's going a little above there. All right. So again, you can add that to your note point, and you can, you could even draw this graph on your note card. Ask me if you want some with graphs on it. I have note cards that have like the grid. Also visualize it. 6, identify any relative maximums and relative minimums. So relative is when it changes endpoint. Like here, it's only going to start increasing. It has to be where, like if it's a maximum, it goes from increasing to decreasing. So hard if you need it. So like if it's going increasing, it's going up first, and then it starts coming down, that would be a relative max. Decreasing, and then it starts increasing, that would be a relative min. So it's changing directions in the middle of the graph. It can't be one of these endpoints. It says identify any, so I'll just go over all of them. So for the maximum, and here we do y value only. So again, that's going back to like the range where we're just looking at that y value only. So that's how you're going to see it on the test. So that might be a good thing to add here. So absolute max and minimum. So max and min y value only. So find so here it goes from increasing, decreasing. So this would be a relative max. So that was our highest point here. So I know the y value was 0.8. Relative max, I could say 0.3. Another point where it starts changing is about right here. It's increasing 2, and those would be our two relative max. And then relative min is looking like this, where it goes be right here. It was decreasing, and then it started increasing. That's at -8 on the y-axis. And then over here is another point where it was decreasing, and then Number 7, identify the absolute maximum and minimum. These are the very highest and lowest points. So going back to all the very highest point, go back to where you wrote your range. We use the lowest and the highest point here, so it's going to relate to this because endpoints are included. So I know that my is this lowest point here, so it can be an endpoint, and that's at -9, y value only, and then absolute max is the very highest point, and then 0.3. All right, and then number 8, identify one positive and negative interval. Using domain and range for your notation. So just look at the x values here. So positive intervals, let's look at those where it's increasing. So the graph starts increasing. So we could say -9 less than or equal to x less than or equal to -7 is one positive. Or, which, if this is -5 and this is -4, again, I'll have exact ones on the test, but this maybe or so, less than or equal to x, less than or equal to, and then it rises up to -2 on the x-axis. Would be where it was decreasing, so it'd be kind of in between these points. So from -7, it's decreasing on the x-axis, so -7 to -4.3. And the point would be from -2 to 4. And then I just realized I missed this last point over here. That's another increasing one. So that would be from 4 to 8 on the x-axis. So be familiar with how to tell. Remember, from left to right, if it's going up, it's increasing, and then left to right, if it's going down, it's decreasing. All right, next page. All right, next concept. Implementations. So find the slope between the following points on the line. So if we're given two ordered pairs, we want to use that formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This would be a great thing to add to your note card. And maybe even put this example that we're doing on here if it helps you. Sometimes, just looking at the formula, you're like, how do I use that? So if it helps you, what I go over on this study guide, add it to your note card if you need it. The x sub 1, y sub 1. So it kind of helps me to write that under the numbers to help me keep track. And then this is the second ordered pair, so it's our x sub 2, y sub 2. All right, so 4 over, and then my x sub 2 is 3 minus -1. Remember, when we have minus and negative, it becomes positive. And remember with parentheses, if I have a negative on that side, that's like -1 times -1, which is +1. So that's another way of thinking about why it becomes positive. Right, 3 plus 1 is 4. Always simplify, so if you need to, you have access to your calculator. Remember, use that green alpha button and then press the button. 6 over 4, -3/2. Another way you could do it is you could just type -6 divided by 4, and you could get the decimal, but let's say on the test it's only in this fraction, and then I can convert it to a fraction. So there's a couple different ways to do that. And then let's say you get your fraction answer, but on the test you see only decimals. Convert it back to decimal. So it's good to be familiar with those functions on the calculator as well. So it'd be -3/2 or -1. You're familiar with simplifying those fractions. All right, then we have on a graph. On the graph, we want to find the rise over run, which is the same method over here, a change in y over a change in x. All right, so pick 2 points that are exact ordered pairs. This one on the y-intercept looks exact, and this on the x-intercept. Left to right, this is going down, so I know it's going to be negative. I'm going down 2, that's -2, right 1. -2 over 1, which simplifies to -2. All right, number 10. Gets to work, he's asked to clean a 175-gallon reef. I'm going to circle reef tank, circle my key numbers. finished draining before he leaves work. He measures the amount of water that is draining out and finds 12.5 gallons drain out in 30 minutes. So he figures that the rate is 25 gallons per hour. All right, so now we are answering these 3 questions about this situation using the table and graph. So what is the y-intercept and what does it represent? So y-intercept, remember where it crosses this y-axis here. So that would be at 0, 175. And time in hours, we have water, gallons. So time is my x, water in gallons is my y. So if, this is our x, this is our y. The tank has 175 gallons in it, which is the starting point before he starts. B, what is the slope of the line? What is the interpretation of the slope of the line in the context? So you can use the table to find the slope. You can use the graph. Not in this video yet. Let's use the table. So change in y. What's happening? Now, sometimes they're going to give you a table where it's not the same between all of the numbers. So from 175 to 150. And also, it goes back to this formula. Subtract backwards. Take the you're subtracting by just by looking at it. You can take the second number 150 minus the first number 175, and then same with your x values, 1 minus 0. So if I go to my calculator, 150 each time. 1 minus 0 is 1. And then that equals negative 25. And then we had done x. If we kind of draw another line next to it, on the y-axis is gallons. This is where we just look at the units. And then on the x-axis is hours. So it's hour. The tank, and he was draining it, so I could say the tank is draining at of 25 gallons per hour. And going back up to the context, it did tell us that. So you make sure you read carefully because it gave the answer right there. When you see that word per, now it's not always the case. Sometimes it might use per. Slope, because that's a rate, gallons per hour. We're giving a rate per hour. What is the reasonable domain and range, and what do they represent? Your graph. So if I go my furthest left point and then my furthest right point, and then from bottom to top, so my domain would be the furthest left point at 0, less than or equal to x, less than or equal to, and the range would go from the very bottom, which is 0, to the very top and the most gallons. It took 7 hours. It took 7 hours to drain at any given time. There was between gallons of water in the tank. Another video for the rest of the packet, but that is all for now. Have a great rest of your day. Bye.